Hey, this is James from Conduktor, and today we're going to talk about querying your Kafka data using SQL. So let's assume that I'm troubleshooting an incident and I need to do a deep dive. The issue is related to my order flow, so I'm going to choose to index my purchasers and my returns topics. I'm also going to index the customer's masked topic, as we're going to come back to that later. And I know that the incident has happened within the last 24 hours. So I'm going to choose to index only 24 hours or 1 day's worth of data. So within moments, I can see the job to index my data has kicked off through the presence of this Conduktor SQL consumer group. This is great because I can make use of Conduktor's broader capabilities to monitor the lag of the topic ingestion job and immediately understand the freshness of the data that I'm querying. So let's take a look at the data inside one of those topics first. And I'm going to jump into the purchasers topic. You can see that I'm using an Avro schema and the raw data looks like so. So here we have a JSON message with the customer ID, the product ID, the timestamp, and the quantity. Now I'm going to jump back to the SQL tab, and in index topics, through the presence of these topic table names, I can now see that my data is available to be queried. So let's try a simple select star on one of those tables. And as I'm typing, you can see I'm prompted with the names of the tables that I have available to query. So let's query the purchasers topic. And voila. Here you can see that both the message metadata, such as the timestamp, the offset, and the partition, along with the business data, such as the customer ID, the product ID, and the quantity, inside my Kafka message has been flattened into a columnar format. We intend to provide more configuration in the near future over the metadata landing in the table schema, enabling you to do things such as analyze the compression rate inside a topic to assist with optimizing storage costs, or analyze the various schema IDs used within a topic to assist with schema evolution tracking. So let's take a look at one of the most typical use cases for Conduktor, finding a needle in a haystack. What we mean by that is finding a specific message inside a topic. So let's say I need to identify a specific purchase by a specific customer. We're using a really simple filter condition. There we go, we found our record. This should all look very familiar. Let's look at something slightly more interesting, perhaps where I need to aggregate data over a specific interval. In here again, and there we can see what I'm able to do is I'm able to count the number of messages within a specific period that match some criteria. So in my case, the number of purchases on a given day. So let's look at something even more interesting. Let's look at maybe joining data across multiple streams. So this is really interesting because let's assume I need to correlate data across multiple topics, and I can do that here. So as you can see, I'm able to correlate data between my purchases and my returns topics and enrich that data set with the return info. And lastly, I'm going to demonstrate how this is all wrapped with Conduktor's security model. Conduktor has a granular RBAC model, meaning that whenever users are utilizing Conduktor, they're seeing just the resources that they have least privilege access to. Also, you can see here some examples of data policies that I have set within Conduktor. In this case, this is about masking information from developers. This permits developers to access production data for troubleshooting, but not compromise on security and compliance. So earlier we indexed a topic called customers masked, and I wanted to do that so I can also show this. So I'm just going to select data from our customers mask table, and as you can see, those policies are being applied when I utilize the SQL feature to make sure that I'm not exposed to any PII or PCI DSS data based on those policies that I previously set. Lastly, I want to show you that once I've completed my analysis, I might no longer have the need to keep this data available for querying purposes. So within the index topic screen, really easily, I can drop the data that I chose to index earlier. This demonstrates the high configurability and the efficiency of this setup, allowing us to avoid the overhead of creating jobs to store data permanently in a warehouse or a data lake. This is a super flexible, on-demand approach. It enables fast insight without the complexity of traditional ETL pipelines, making data analysis much more agile and responsive to changing needs.